All right, so number 2, off of review packet number 2, mean value theorem. So given our function is square root of x minus 1 in interval from 10 to 50, use MBT to find the tangent line equation with the same slope as a secant line that passes through the endpoints. So really, we're just going to step through mean value theorem. And then from there, we can create our, in this case, secant line equation or tangent line equation. Okay. First things first, we want to take care of the order pair, figure out what that's the first thing we want to do. So we have 2 endpoints here. We'll find f of 10. We'll find f of 50. And from that, we can help find the slope between the endpoints. Okay, f of 10 square root of 9, which is 3. To find f of 50, all right, so all this is doing is asking for the slope between the endpoints, change in y over the change in x. Okay, so we have this piece of the puzzle figured out. And now, mean value theorem, we're just going to take the derivative, set it equal to 1/10, and then that is going to help us figure out the location on the curve where the slope of the graph is exactly 1 over 10. F prime, go through chain rule. Outside's derivative multiplied by the inside's derivative. Clean this up. Okay, we take our derivative, we take our slope, set them equal to each other. That's what mean value theorem is asking for us to do. And then when we solve for x, we'll be able to find the location of this particular slope. Okay, from here, I can cross multiply and solve for x. Okay, divide both sides by 2. Square both sides. Add 1 to both sides, x equals 26. All right, so we have the slope. We have part of the order pair. Now, because we're asked to find the tangent line equation, all we need left is to find the y value. So we'll take 26, put it back into the original function. Which is square root of 25, which is 5. All right, so that's the second piece that we need to build our tangent line equation. All right, so now we have our point. We have our slope. And now point slope form. There we go. Okay, any questions here?
No, I understand.
Okay, good. Let's see. There's also number 4, which is finding points of inflection. Let's try that one. Okay, now what value of x does the graph have a point of inflection? Okay, so to find our point of inflection, we have to make our way down to the second derivative, and then from there, critical point, second derivative sign line, and then look at if there's a change in sign. So let's get this ready for each of the derivatives. Okay. Brought both the x's up so I can go through power rule easily. Y prime. Okay, keep going, y double prime. Okay, so here's our second derivative. We know that our critical point is going to come from this variation here. All right, so it's easiest to find critical points if we have a common denominator, if we have one fraction. So I'm going to balance my fractions here to get a common denominator, and then I can look for my critical points. Common denominator is x to the 5th. And you multiply this by x, keep this the same. Okay, we set both equal to 0. But 0 is a vertical asymptote. So we know that the only really true candidate that we have is at 2. So even though we can create our second derivative sign line with 0 and 2, 2 is the only value that that the function actually exists. So this is the only candidate, but we still have to confirm that there's a change in sign, right? So negative over negative is positive. So 6 minus 12 is negative over positive, which is negative. And then 3, I get positive over positive, which is positive. Yeah, so we got to be careful here. Even though there's a change in sign, 0 is not going to be a valid point of inflection because it doesn't exist. It's part of a vertical asymptote. So POI only at 2. Because our second derivative changes signs. Okay, questions there?
No, I got it.
Okay, good. Let's see. Number 6 is a bit of a variation of chain rule that's a little bit more involved. We want to find f prime of 1, but before we find f prime of 1, we got to find f prime of x. Now notice that this is inside the g function here, so this is chain rule. This is not g of x times x plus g of x. This is g of x plus g of x. So there's going to be some nested chain rule here. Okay, so let's find f prime first, and then we can move on to f double prime. I'm sorry, then we can find f prime of 1. So chain rule says outside derivative times inside derivative. So the outside derivative, g is going to become g prime. Keep everything inside the same. And then next up, multiply by the inside derivative. So inside derivative, x becomes 1, and g of x becomes g prime. Okay, so chain rule. This is outside derivative. Followed by inside derivative. And if we want to see things more clearly here, there's the outside portion is my g bracket, g of bracket. And my inside derivative is the x plus g of x. Okay, so again, g bracket becomes g prime. Keep everything inside the bracket the same. And then we move on to the inside derivative. X becomes 1, and g of x becomes g prime. Okay, does that make sense so far?
Yes.
Okay, so next, we want to find f prime of 1. And replace every x we see with 1. All right, so g of 1, we're going to go to a graph here. Our graph is going to help us out. So g of 1 is whatever that y value is, which is 3. So g of 1 is 3. I'll put that off to the side. But we also need g prime of 1 down the line. So g prime of 1 is asking for the slope of the g graph at 1. And the slope of the g graph at 1, we see that this slope here, this line, is from here to here, right? Rise over run. down 2 over 1, so it's a slope of -2. Okay, we'll put that to the side here. All right, so let's fill in what we have. So 1 plus g of 1 is 3 times 1 plus g prime of 1 is -2. All right, keep going. G prime of 1 plus 3, so this is g prime of 4 times -1. So we need one more slope value we need to find, and this is the g graph at 4. So we go to the g graph at 4. And this point here is part of this line segment, and this line segment has a slope of from here to here. So I go up 2 over 3. 1, 2, 1, 2, 3. So 2/3, right? This highlighted, bold segment here, thickened line segment here is a slope of 2/3. Okay, so final substitution that I can make here, g prime of 4 is 2/3 times -1, which is just -2/3. Okay, quite a lot going on here. Okay, good so far, Tim?
Yeah, I get it.
Okay. Number 9. This is an EVT problem. Find the maximum value. So EVT, we can find, we know we got to test endpoints and critical points, see which of those has the highest and lowest y values. So we know the endpoints, so we know we're good there. Just have to look for the critical points, which is coming from f prime. Set equal to 0. And factor this out here. Continue factoring, multiplies to be 2, adds up to be -3. Solve for x minus 2 equals 0. X minus 1 equals 0. We get 2 and 1. So 2 is already an endpoint, so that's just a duplicate. So we'll just test it once. And then 1 falls nicely inside the interval, so we keep it. We're going to be involving this critical point. Okay. So we'll find f of -1, find f of 1, and f of 2. So -1 here. -24, plug 1, 2, plus 9, plus 12, 2 in. Okay, 16 minus 36, negative 20 plus 4. 4 minus 1 is 3. Okay. So it's asking for the maximum value. So the max value is the y value. Right. Highest y value that we see is 4. Okay, let's finish. Let's do one more. Number 11. This is a tangent line equation. Find the derivative. From the derivative, we can get the slope and get the tangent line. But to get to the derivative, looks like there's going to be a quotient rule problem, right? Okay. F prime g minus f g prime all over g squared. Now I'm going to speed things up because I'm just trying to find the slope, so I don't really have to worry about the cleanup, right? Just start putting the 1 into the derivative here. So 4 minus 15 over 4. Let's see, 2 plus 3. Oh, I messed up. I copied the problem wrong. 2x plus 3x minus 2. Should be 1. Should be 1. Okay, so 2 minus 15. Okay, so there's my slope. Okay, and finally, point slope form. Take my ordered pair. Take my slope. All right, any questions there, Tim?
No.
Good. So yeah, we'll continue working from, we'll work on chapter 5 concepts today in class. And then we'll have another help session this afternoon. I'll continue going over problems from packet number 2. All right, I'll see you in class, Tam.
Thank you.
Okay, see you.